Good morning students. This is Bhavani working as a contract lecturer in computers department GPW Medak. So subject data structures through C. That is in third semester. We entered into the third unit, that is in sorting technique. So today's topic we will be discussed about the selection sort. So in the previous section we discussed about the what is in sorting and why we need the sorting and what are the methods, what are the techniques. We studied it. And bubble sort example, algorithm for bubble sort, program on bubble sort, time complexities, space complexities also we discussed. So what is in sorting? We know that sorting is nothing but arranging the given list of elements in logical order. It may be ascending or descending order. Yes, why we need the sorting means the main application of sorting technique is in database, dictionaries, telephone directories, etc. These are all the examples we can be take it. In the database also, what the data will be storing, it will be arrange the orders in ascending order or descending. It will be in order arrange. Yes, in the dictionaries also, or the full numbers also, it will be arranged in order. Telephone directory also, it will be arranged in order. So this is the main examples we can be taking. So in the home or in the class, whatever it be, if you have the library will have the lot of sections, will be have a lot of books are there. So which book from which section we don't know. So at that time what we have to arrange in order, where each EC section books has to be arranged in EC section only, and computer section books we have to arrange in the computer section. So then at that time it is an easy to access, it is an easy to retrieve that. So which one, the time consuming and the space, if you are keeping lot of books and together, it is for the picking it is very difficult, and it will be taking the time as well as the space also. If we are arrange all the elements in order, then it is an easy to retrieve and easy to access. So which one I need it. In the house also, all the items, the kitchen items has to be keep in the kitchen only, the bedroom items we should be keep in the bedroom. In the hall, what we need it, if you have the library, the study room is there, the books has to be arranged in the study hall only. If you keep all the books, if you are there, the books should be keep in the kitchen and kitchen items are keep in the hall. So what it will be, we have to make the searching. It is very difficult, where it is, it takes the time. If we keep in order where we need it, so then for that, if you want the books, we have to go for the study hall. If you are doing any kitchen items, then if you are cooking anything, if you are in the kitchen room only, all the items are available, it is easy to take it. Yes, so like that, all we, even in the, not only in the kitchen, not only in the house, even in the libraries or wherever we can be, we have to keep the order, we have to keep the each element in order. So that is called the sorting. And next, sorting algorithms will help in arranging the records or the files in an order such that retrieving makes easy. For retrieving it is very easy. So that is then why we are using the sorting. What are the methods of sorting we having? Bubble sort is there, selection sort, insertion sort, quick sort, and merge sort. So what is an bubble sort? Bubble sort is the smallest and simplest sorting techniques. So when we are compared all other sorting technique, this is the smallest one, but the sorting technique will be compared all the adjacent element and interchange if necessary. So it will be compare each element. In the bubble sort, it won't be select, it will be compare, it will be check, and it will be swap. Okay, it will be comparing each element and then it will be interchange. So that is an bubble sort. And coming to the selection sort and bubble sort algorithm programs, all we saw in the last class only. Now coming to the today's topic, selection sort. Selection sort is one of the simplest sorting technique. The word selection itself speaks picking up one element each time which is pathologized from a list. In this sorting, successive elements are selected in order and placed into their proper sorted position. So selection sort is the simplest sorting technique. So in the selection, in the name itself is that we have to select one item. In this in the bubble sort, first we will be compare each element, comparing as well as interchanging. In this we no need any first we will be compare. If the smallest only, we have to swap. Always we no need to. So the name itself is there. First it will be comparing all the elements. So which is the smallest we will be select, then we will be do the swapping part, that is an selection. For example, if you go for the shopping only, we will see all the items, which is the best one we will be take it. So like that, which is the smallest one, then you need to swap. We will be compare all that. So here also, how selection sort works, how it will be working. First, select the smallest element from the given list with the first one. Okay, which is the smallest element in the given list, we don't know. First we will be search. We while writing we can be know, but computer has to be do. How? So first select the smallest element from the given list and swap it with the first one, that is a pass one. And next second to select the second smallest element from the list and swap it with the second one, that is a pass 2. In the subsequent passes, the next smallest from the unselected is chosen and swapped with the next in order. This continues till all the elements are sorted. Okay, till it will be selected. How the smallest one is selected? How we will be? In the first pass we studied, that is an first to select the smallest element from the given list and swap it with the first one. This is the pass one. So in the pass one, how it will be going, we will be seeing. How the smallest one is selected, the pass in pass one. Compare the first element with the second one. The first element, what is the given element, the first element with the second one. Find the smallest between them. 1 and 2 elements, first one and second one element, first you have to check it, we have to compare, and from that which is the smallest one we have to compare. Okay, find the smallest between them. Compare the smaller with the third one. From the 1 and 2, which is the smallest, we got it. The smallest number and the third number we have to compare. From that which is the smaller, we have to find it. So compare the smaller with the third one, find the smaller from them, and so on for till all the elements are exhausted. Ultimately we pick up the smallest one. So the first pass only we are understanding how we will be compare. We are comparing the one and second element. Okay, now we are comparing, and from that we are finding the smallest one. We got it. And next one, just we are comparing, we are not swapping here. And second part, again the smallest number, comparing the smallest number, and third one, find the smaller from that. After finding the smallest one, we have to pick and we have to interchange with the first one. Swap the smallest with the first element. I am telling that only. Find the smallest with the first element in the list, so as the smallest element is placed into the proper sorted position. So here, which is the smallest one we are identifying from the first to till the end. If we got the smallest, then we have to keep the smallest number in the first element. That is the proper position. How the smallest one is selected? With example I am taking. Let us to understand how the smallest element is selected and swapped with the first element. So as the position the smallest in its place. Take an array. For the list we have to use the array list. I am taking the 8 elements in the list. So this is an example I am taking. How the smallest one is selected? With an example I am taking. I took the example 25, level, 30, 8, 29, 3, 56, 16. So these are the 8 elements. So which is the smallest? We identifying only, we know that 3 is the smallest one. So to pick the 3, so what the processing part we have to do? What is the technique we have to follow? Pass one example. I am taking the array. This is an array list. And next, first we are comparing 25 and 11. Which is the smallest one? 11 is the smallest one. Step 1, smaller 25 and 11 is answer is 11. Next, again I am comparing level and 30. Which is the smallest one? Level is the smallest one. So level as the output. Second, step 2, smaller level and 30. The reason which is the 11 is the answer. Next, again 11 and 8. Which is the smaller? 8 is the smaller. So output should be the 8. Again level we will be keep. Now 8 and 29 has to be compared. 8 and 29. Which is the smaller? 8 is the smaller. The output will be 8. Output is an 8. Next, 8 and 3. Which is the smaller? 3 is the smaller. Okay, 3 is smaller. Next, 3 and 56. Till the end we have to compare all the elements. 3 and 56. 56 is an higher, 3 is a smaller. So 3 is an output. And next, 3 and 16 has to be compared now. 3 and 16, the output will be the 3. So what we have to, the 3 has to be replaced with the, we have to interchange with the first element. This is an rule we have to follow. Three. In the pass one, the 3 is selected as the smallest after gone through 7 steps. I saw all the steps. 7 steps we used. So which is the smallest we got it? 3 is the smallest. What we have to do? I am selecting the 3 and 25. Now replace. Now replace is nothing but swap. 3 will be replaced with the 25 and 25 will be replaced with the 3. Following the slides, swapping. Swap. I got the output. The 3 will be placed in the 1, 11, 30, 8, 29, 3. Now not the 3, you have to keep the 25, 25, 56, 16. So this is an output we got it. Now pause 1 is completed. First smallest element placed. Okay, in pass 1 we got the which is the smallest element, we got it. So like that we have to go for the next pass. Compare the second element in the second element with the third, because the first element we don't need, we placed proper position only. Now second and third we have to compare and find the smallest between them. Next compare the smaller with the fourth one, find the smaller from them, and so on so far till all remaining elements are gone through the same procedure. Ultimately we pick up the second smallest one. Swap the second smallest with the second element in the list, so as the second smallest element is positioned in its place. So how it will be? Let me see second pass. This is my array 3, 11, 30, 8, 29, 56, 16. This is my array. Now what the first we have to remove, the second one we have to take. Now 11 and 30, which is the smallest one? 11 is the smallest one. The output is 11. Now 11 and the 8. 11 and the 8. So output is 8. Again 8 and 29. 8 and 29 we will be compare 8 only. Next 8 and 25 we will be compare, the output will be 8 only. Next 8 and 56. 8 and 56, the output is 8 only. Yes, and 8 and 16 we will be compare, the output is 8. So from here we got the which is the smallest one. 8 is the smallest one. Yes, 8 is the, after 6 steps in pass 2, the next smallest element is 8. Now 8 has to be replaced with the, we have to swap it with the second element in the list. 8 is to be swapped with 11. We are swapping. Okay. 8 has to be replaced, came to the second place, and level has to be came to the smallest number, that is an 8. This is one swapping part. Second smallest element we got it. How the smallest one? So for the subsequent passes do the same process and so on. The next smallest element once into their proper sorted position, we will be get it. Pass 3, let me see the till the end we will be continue. We got the output 3, 8, 30, 11, 29, 25, 56 and 16. First two elements we got it. Now second element, that is in 30 and level we have to compare. So which is the smallest one? 11 is the smallest one. Again 11 and 29 we have to compare. Again you will be get the 11 only, and next 11 and 25 we will be compare, we will be get the 11 only, and 11 and 56 we will be compare, you will be get the 11 only. Next 11 and 16 you will be get it, you will get the 11 only. So the smallest, the second pass, in the third pass we will get the next third smallest element, that is an 11. So level has to be replaced with the 30 element. How it will be swapped? Let me see. 11 is the smallest. So after 5 steps in pass 3, next smallest element in is 11. What is this is in pass? Level has to be swapped to 30. Next to 30, and as usual the numbers has to be kept. The third smallest element we got it. Now fourth. In the fourth element, and we have to compare with the smallest element. Now 30 and 29, which is the smallest one? 29 is the smallest one. Output 29. 29 and 25, we will be get the 25 is the smallest one. 25 and 56, 25 is an output, you will be get it. 25 and 16, 16 is an smallest one. Okay. So what we have to do? The fourth element has to be swapped with the 16. 16 is the smallest one. I keep the circle highlighted. So where we have to, after doing the 4 steps, 4 passes, the next smallest element is 16. Now swapping. 30 has to be swapped with the 16. 16 is to be swapped with 30. Now swap. The 16 has to be come to the fourth place. 16, next 29, 25, 56 and 30. Okay, now swapping section is completed. Pass 4. Fourth smallest place. Next fifth element. This is my array. I got the list 3, 8, 11, 16. Now 25. 25 and 29, sorry 29 and 25 has to be compared now. Which is the smallest one? 25 is an output. And 25 and 56 has to be compared. 25 is an output. 25 is the smallest one. And 25 and 30, 25 is the smallest one. Okay. Now which one has to be swapped? 25 and 29 has to be swapped. 25 is the smallest. So after doing the 3 steps, passes 3, we will be getting the 25 is the smallest one. (29), 25. 25 has to be swapped with the 29. Okay. 3, 8, 11, 16 as usual we will be get it. Okay. Now which one swap? 25 and 29. First which one? 25. Next 29, 56 and 30. Okay. We swapped the 5 elements. Pass 6. Pass 6. 29 and 56 has to be compared. 29 and 56, which is the smallest one? 29 is the smallest one. 29 and 30, which is the smallest one? 29 only. So there is no need to swap, I think. Step 2. After 2 steps in pass 6, the next smallest element is 29. In pass 6, 3, 8, 11, 16, 25, 29, 56, 30. 29 is already placed rightly, so no need to swap. If in the right position, there is no need to swap. If it is compare, if you get the smallest only, we have to do the swapping. Step 7. Now which one? 56 and 30 has to be compared now. The 7th element. 56 and 30, the output is 30. Yes, the output is 30. Now swap 30 and 56. Where after one step in pass 7, the next smallest element is 30. 30 is to be swapped with 56. Now swap. How we will what we have to swap? We have to swap 56 and 30. So swapping is done, 30 and the 56. After having positioned the last but one smallest element, the leftover is automatically placed. Okay, which is the smallest one, that is 3, 8, 11, 16, 25, 29, 30 and 56. Okay, now all having the position. After having position, the last but one smallest element is left over is automatically placed. All the elements are placed into their proper sorted position. So here end procedures. How many passes we did it? We did the 7 passes. So observation at the end of final passes. At the end of final pass, the last but one smallest element in the list would fixed at the last but one placed. In the past we have comparison is 1 comparisons and 0 exchange, because the final one and there is no need to exchange. So 0 exchange. In this past we have 1 comparison and exchange. The remaining element is automatically placed at the first place as the smallest element. This method is called ascending selection order, because we are arranging the order in ascending, like 3, 8, 11, 16, 25, 29, 30, 56. We will be arranged like in ascending order, that is the smallest to biggest number. So that method we will be calling the ascending selection sort. The remaining element is automatically placed at the first place as the smallest element. So this method is called ascending selection sort. If the list consists of n elements, we have one comparison. If we have the n elements, what we are doing, we will be compare the one comparisons and one exchange at most. So this is the worst case in the final pass. So we did the 7 passes. So how we are doing, how we are passing. So in the selection sort, the first pass, the first smallest element is a search in the list and exchange with the first element in the given list. So like that we have to do the pass. So in the selection sort, which is the smallest one, we have to select, and next which is first we have to compare all the elements. So in the first pass, the first smallest element is first we have to search. For the searching, we have to compare all the elements. So for finding the smallest one, we will be comparing. We have to compare all the elements. First to compare, and how many passes, how many times we will be exchanging. We have to see all the we have to search, and then we have to exchange with the first element in the given list. So the second pass also, the second smallest element is search in the list and exchange with the second element in the given list. So this process is repeated until all the elements in the given list are sorted. So selection sort is nothing but selecting one of the smallest element in the given list. Then we have to compare all the elements, and next, which is the smallest one, you have to replace it with the first element, and the second also, in the second pass, the second smallest element you have to compare, and next replaced with the second element in the given list. So like that we have to pass. So if there are n elements in the selection sort, it requires n minus 1 passes. So note, if there are the n elements, how many requires we needed? N minus 1 passes to complete the sorting algorithm. After completion of I passes, the first element is located at where the first place only. After comparison of the second pass, the second smallest element is located at the second place. So after completion of the I passes, ith smallest element is located at the ith place only. The first element is compared with n minus 1. Second element is compared with n minus 2, and ith element is compared with n minus I element. So that is an n number of requires, and n minus 1 passes we have to pass it. Total we have the 7 passes, because the n minus, if you have the n elements, the selection requires n minus 1. So how many passes we did it? N minus 1 passes. So 8 means 7 minus 8 minus 1 means 7 passes. So this is the 5th pass. This is the 7th pass. So all the elements has to be placed. So that's why the noting how many n elements if we are giving, that requires that for the selection sort we required n minus 1 passes to complete. So if I enter the 8 elements in the list, so how many passes we have to do? That is an n minus 1. If I give the list 10, then n minus 1, that is an 10. N is nothing but the number what I entered, that is an 10 number, that is a n minus 1, that is a 9 passes it has to be do. So all the elements are placed into their proper sorted position. So here end procedures. So 7 passes. So observation at the end of final pass. At the end of final pass, the last but one smallest element in the list would fixed at the last but one places only. So in these passes we have one comparison and there is no exchange. In the last, in the final, if we have the compare, we can be compare, but there is no exchange, so that's why 0 exchange. the remaining elements, the remaining element is automatically placed at the first place as the smallest one. The first place we have to keep the smallest one. The remaining element is automatically placed at one smallest, the first place as an smallest only. It is an automatically. This method is called what? The example I took it, that is an ascending order. The smallest to biggest number, small to bigger. So that's why this method is called ascending selection sort. If the n list, if a list consists of n elements, we have comparison one comparison and one exchange at most is the worst case in the final pass. So selection only, selection itself is the name itself is there. So we have to select only one which is the smallest element. So in the first we have the passes as the stages. So to pass, to move from one element to another element, we have to using the passing techniques. So the passing techniques in the selection sort, then n number of n minus, if you have the n elements, the selection sorts required n minus 1 passes has to be complete the sorting the algorithm. So if the first pass, the first selection, the first smallest element is search in the given list, and next what we are doing, and exchange with the first element only, not which is the smallest behind, not the first element in the given list. This is automatically it will be solved. That's why we wrote the first point. The remaining elements is automatically placed at the final place as the smallest one. And the second pass, the second smallest element is a search in the list and exchange with the second element only in the given list. So this process will be repeated until all the elements in the given list are sorted. So this is an selection sort. This is a very simplest sorting technique. So which is in the selection sort, first we have to select and we have to compare with the, we have comparing all the elements, comparing, but exchange will be done with the first element only, the first element in the given list, then we have to exchange. And second, from the second and the third you will be compared, second and fourth we will be compared, and which is the smallest one, and we have to exchange with the second element in the given list. So and so on the elements. So these are the notes we have to remember. So if n elements selection sort requires, then n minus 1 passes we have to do. So already I said it. How many list in the list? I took the 8 elements, 8 values I entered. How many passes I end with? N minus 1. That is then 7 minus 1 passes has to be complete the sorting algorithm. After completion of I passes, I pass, that is the first pass, the first smallest element is located at the first place. After completion of second pass, second smallest element is located at the second place. So after completion of the I passes, I smallest element is located at the ith place. The first element is compared with n minus 1. Second element is compared with n minus 2, and I is compared with n minus I, not the n minus n minus I, till the ith place, well, till that we will be comparing. So this is how we are comparing with the example I told. Next class we will be discuss the algorithm of the selection sort, how we have to write the algorithm, and what are the steps we have to follow, and what are the passes, and we'll take the another example also for the algorithm, and next example the program we will be, and what are the time analysis, that is in time space, and the time complexity and the space complexity is what we need it, what we have to do, all we will be see. So selection sorts are the very smallest sorting techniques. It is a very easiest only first we have to select the smallest one and we have to exchange with the first element. So that is a sorting technique we will be using. Okay, thank you so much.